Thanks a lot, Antonio, for doing this speech, and we listen to your time.
Thank you very much for the introduction, and it's a pleasure to meet all of you. So yes, as Carlos introduced, the topic of this presentation is the data sharing in virtual anthropology. This is very important. It's very important, in my opinion, to find a way to make all the research that we do, not only the 3D model, but also the numeric data that we produce. It's important that they are replicable. So when we talk about virtual anthropology, we mean an interdisciplinary approach to the study. So what we can do with virtual anthropology is the application of some medical devices like a computerized tomography to acquire the 3D model of a human fossil or a skeletal material. And what we can do that once that we have defined the 3D model is we can measure some parameters like we can extract shape variables, like in this case with geometry morphometrics, but we can also extract and study virtual cavities like the endocast, the maxillary sinuses, and so on. So, but now to the medical field, but also thanks to the computational capabilities that we have now. For example, this is an extreme example. In this work, Timmerman and colleagues, they emulate different climate variables in the last 2 million years. So, and to do that, they use the most powerful computer in the world. This is a supercomputer. It took like 6 months to produce this kind of data. So during this presentation, I would like to show you a different strategy to share your. So when we talk about virtual anthropology, is the digital acquisition. So all of us, we are experts in digital acquisition, and we can use different techniques like laser scanning, photogrammetry, or computerized tomography, or MRI. But for each of one of these techniques, there are some. We know that with laser scanning and photogrammetry, only the visible parts are acquired, so we have to be careful to the hidden spots. And in addition, with the photogrammetry, we have to scale manually the 3D model. And it depends by camera or the resolution of the device. The computerized tomography is a very useful device, instruments. The problem is that it's quite expensive. And of course, we can study different region with different machine, because it depends by the resolution that we want to use to acquire the skeletal material. And also in this case, we can have some artifacts due, for example, to the presence of metallic part, as in this case, this artifact, named the beam hardening, is due to the presence of dental filling. So the next step, once that we can use create 3D models, we have to be careful to some parameters, some aspects. For example, when we use photogrammetry, it's important to share also the raw pictures that we use to create the 3D model, because there are different software that now we can use. And also the resolution and the quality of the model, often it depends by the skills of the user. So I think that it's important to share the 3D model, but also in this case, it's very also important to share the raw pictures if this is possible. Another problem that is often underestimated in virtual anthropology is a conversion from the physical object to the digital object by using computerized tomography. Because sometimes we perform manual segmentation, so we decide slice by slice or case by case what material we want to select to create a 3D model, or in other case we use a single threshold. This means that if we have a total body CT scan and we want to create a 3D model only for the soft tissues, we can use a range of threshold. If we want to extract of the cranium, we can use another ranges only. So in this case, you can see as, for example, this is the femur bone, and if you change the threshold, express it here as ounce-width unit, we have a different resolution of the diaphysis, the epiphysis, and the cross-section. So also the shape and the thickness of this cross-section can change according to the threshold that we defined. And there are some papers that they tested the effect of different threshold or different algorithm to the resolution and replicability of this model. And also what we do, especially when we use laser scanning and photogrammetry, we apply some filters to improve the quality of the model, to improve the appearance actually of the model. But also in this case, it's better to, so the decimation filter is quite useful because sometimes we are interested in creating a lighter version of our model, maybe also for data sharing. But for example, other filters like smoothing, they can add further noise and bias. So it's better to at least make notes of all the parameters that we used when we created the 3D model. This is the focus about the CT scan. Because in this picture, here we have the femur bone, and here the color represented the radio density of these bone elements. So blue means that here the radio density is low, and the red means that here the density is higher. So, and this is a plot showing the optimal threshold, the single threshold that we can use to process each of these slides. And so imagine here some vertical lines. And if we want to study the epiphysis, we can use very low ounce-field unit threshold like this one. But if we want to use to process and to create the model of the diaphysis, we should use higher values of ounce-field unit. So this means that if we want to study the epiphysis, and in this case, we can use these thresholds. But if we are interested in studying the distribution of the cortical bone along the diaphysis, we should use. So this is important because it depends by the aim of our study. We have to think about also to these parameters. But if we make notes of the parameter that we use, at least we can we are sure that our 3D models are repeatable and replicable. So this is very important. But once that we have the 3D model, what we do is we define something from its analysis. For example, in this case, this is a Neanderthal cranium of Sarcopastore 1. And here there are some semi-landmarks that we use to study the shape of this Neanderthal, or this specimen in the context of Neanderthal and the Middle Pleistocene variation. So once that we have this, sometimes we cannot share the 3D model itself because it belongs to some institutions, or we don't have the credits to share 3D models. But once that we define some numeric data on it, like in this case with semi-landmark coordinates, your institution yourself are the owner of this kind of data. So usually there is not there is not any problem in sharing the numeric data that you produced by defining, by studying this specimen. And anyway, it's important when you get access, for example, to some material from another institution to write and ask for a project agreement. So in this way, you can get access to some fossil material only for that specific project, and you can also ask to put in the project agreement that you are that you can share the numeric data that you produced during the project. Now, is some example of data sharing in virtual anthropology. This is a paper that published by Stefan Schlager, me and colleagues. And here, for example, we propose a new method to symmetrize distorted specimen due to taphonomic processes. So in this case, this was a new function, a new method. So it was very important to test the performances of this algorithm compared to previous ones. So what we did was to share in R as data a lighter version of the cranium of Sacco-Pastore 1, as well as the landmark semi-landmark configuration, and the entire script reported in the paper as supplementary information. So in this case, we supply to the users all the information, all the material to reproduce exactly the same picture that we reported in the paper. And this was possible. The data using a lighter version of this cranium was not very large. So in this case, it was possible to include all these material in the Morpho-R package. But we included also a simulated case study where we artificially distorted a gorilla cranium, and we apply our method and other methods of particle deformation. So in this case, we had 3D models of gorilla, our script, the landmark configuration. And in this case, the size of this specimen was quite high. So we decided, for example, to use another open repository. This is a IPHES-CERCA. And this is very useful because you can share on these open repositories some files. You can monitor, for example, the metrics about the data that you're sharing, and so on. I forgot to tell you that yes, in this case, so when we share this data on IPHES-CERCA, on Zenodo, on this kind of open repository, usually we create a frozen version of your repository, and you can link also a DOI. So in this way, you are sure that your data cannot be modified and edited in the future. So in this case, you have a real data sharing of data. And this is another example of a paper published by Antonio Profico as leading author on the study of the frontal bone in modern humans. So here we decided, for example, to use this platform. This is this open repository, Zenodo. And here we decided to create just two objects in R, because all the data were performed in R. So we created just two objects, one with all the data. So the landmark, semi-landmark configuration, a reference surface, the information about the individual that we used, and so the biological sex, the ancestry, and another object with all the script. So in this way, we were able just providing two single objects stored on Zenodo to ensure that all the analysis that we reported in the paper are replicable by other researchers. And also we shared also all the methodological design that we applied in this case. And Zenodo is a free open repository online, and we can link a DOI like it was a paper to your data. And you cannot edit when you associated, or you cannot edit the folder that you are sharing. But if you want to add further materials, or you found some bugs, some errors, you can create a new version of your data with a new DOI, and you can share again all the material that you use in your research. And this is the case of a research by Timmerman published in Nature, when you cannot share everything, because in this case, the amount of data that they product is ridiculous. So you cannot do that. So what they did, they create some video of the evolution of the ecological niche and other human species. And they created this a page on this website, for example, by using the data that they produce. So in this web page, what you can do, you can just insert the coordinates of a place, like Tarragona or like an archaeological site, and you can visualize all the climatic variables in the last 2 million years. So this is a very important tool also for other research. So this is we talk about how we can share the numeric data that we produce from the analysis of the digital data. But if we want to share the digital data itself, what we can do, we can use some of these platforms. For example, MorphoSource is a very useful resource because here you can find a lot of information about the digital models that you want to download, or when you have to upload a 3D model, you have to insert a lot of parameters, like, for example, if it is a model from photogrammetry, you have to define the number of pictures that you used, the brand of the camera, and other parameters. So this is very useful because when you download, for example, a 3D model from MorphoSource, you have also all the parameters that we talked before. And after this Netpost that is online again, I checked and it works. And so you can find the Netpost at this link. Morpho Museum is another very useful repository, and you can find a lot of big models, and also some models of the inner ear and so on. And it's useful because there is also a journal associated with this virtual repository. And it's impossible to don't mention Digimorph. Digimorph was the first online repository where you can download a lot of 3D models. And also there are also these virtual repository when you can get access to modern humans, primates, fossils, and so on. Talk about the New Mexico database. When we use CT scan, for example, of recent humans, it's very important to be sure that if you are sharing something like that, to be sure that all the information, the sensitive information is removed. So we have to be sure that we cannot associate a 3D model to an individual. So we have to remove some information like the postal code, I don't know, and other information. So in my it's very useful when we start a project to define a protocol to make our results replicable. So, for example, we can define some criteria in the acquisition and in production of the 3D models. So, in this way, we can make notes of all the parameters that we used in the creation of the models, and we can think also also about how we want to store the numeric data that we are going to produce. We can create objects in R, of course, but it's not important using R in this case. We can also produce some tables in Excel or by using other software. So, but I think it's very important to decide the criteria, to decide also to create this numeric data, in which format, and where to store this data. And if you use R, is very useful to export your script and to add comments on it. In this way, the researchers can understand better each step of the script. And lastly, we have choice for what concerns the open repositories. For example, GitHub, it's very useful to store our script, but also our data, numeric data. And this is very useful, I think, for a group working in an institution or for the institution itself, because we can create also a private account. So we can create, for example, a private account and a public. And this is useful because during the project, maybe we want to between the components of the team, some data or some script. Is free, as well as GitHub and IPHES-CERCA. And it's not, it's very useful when you want to share data, research papers. Triad is not free, but it works like Zenodo. And all these four open repository, they have the chance to create a linked OI to your data. So in conclusion, I think that when we start a project and when we plan to use 3D models of human fossil material, it's very important, it's necessary to have an agreement with the external institution. And in the agreement, we can also discuss about what kind of data we can share to other researchers. In this way, I think there is no problem in sharing, for example, the data that you produce, like measurements or coordinates of semi-landmarks, for example. But you can, so in this way, the hosting institution is, the external provider is, they can agree to share only part of the data that they produce. So it's very important to describe all the parameters linked to both the digital acquisition and the extraction and creation of numeric data. And yes, it's also crucial to don't underestimate the creating the digital model, like for example the application of digital filters or the choose of some thresholds when we want to create a 3D model from computerized tomography scans, for example. Yeah, it's important to be familiar with the open repository like Zenodo and GitHub. There are a lot of example tutorials on YouTube, and both of them they have a user-friendly interface, so it's not complicated to use that. And also, lastly, I didn't know, but I discovered yesterday that data sharing increased citations. So probably because if you share your data, other researchers, a consequence is to get more citations. Thank you very much.